Hey, welcome back to Munro Live, boys and girls. Today we have Carl again. You're probably getting tired of him, but hey, he knows his stuff, so he's going to be coming. But we're also joined by Sue Smith, who's one of the managers here, and she's going to work with Carl and tell you all about the IP, the instrument panel. Now, this Model S Plaid is a little different than the Y and pretty much any other car we've seen. So what these guys are going to do is they're going to come in and they're going to go into detail on the componentry that you'd see in the IP, and then the comparison between the cross-car beams for the Model S Plaid, the Y, and what we saw in the Mach-E. So with that, I'm going to get out of the way, and I'll let Sue and Carl take over. It's all yours.
Thank you.
Hello. So we're going to kind of start from the top down, the things that the customer is going to see. And in my experience in engineering, I've always done the decorative things, the things you see, the things that you touch, working from studio on. Once we get deeper past that, we start to get out of my layer of expertise, and Sue's going to help us out. All right, so we have a wrapped top pad. This wrapped top pad goes to a polypropylene glass-filled substrate. I hate glass-filled substrates. Now, it can be one of the best things to use for this type of a product, but the problem is you have to flame it. Polypropylene will not directly accept the adhesive. Because of the flaming, you expose the fiberglass within the polypropylene. When I was on the assembly lines helping people out, I would see that they would all have to wear long sleeves or some sort of protective sleeve because of handling those parts after flaming. It would get itchy and it would just get terrible. Going past this, we have this screen. Now, when we first saw this screen in the vehicle, we thought, oh, that's one big continuous piece. But we've kind of learned it really isn't so once we flip over and look onto the back side. So continuing from that top pad, we have a polypropylene top pad, which is flamed and then wrapped. Now we have all of this in here, which includes ductwork and then the frame that is supporting the passenger airbag. This is a separate injection molded piece that is then welded into the top pad. Lots of times we would call this a structural duct. So this gives you a lot of stiffness and a lot of structure, but I don't have a separate bracket. I don't have a bunch of separate features. I can integrate that all into one. It also helps with packaging environment. These ducts, the top pad itself becomes part of the duct tube. Sue, the screen. So let's flip this around so that you can see what we're talking about when we talk about the screen.
So this screen face, this surface, it's beautifully executed. It's one single piece of covering across the entire front of the dash, which that's a beautiful execution. It's so clean. It's iconic Tesla styling. What you experience behind this screen, however, this face, this surface, probably polycarbonate face, is that the actual display screen is a subset of that, and it goes from here to here. The other components that attach next to this display screen and come across the back surface of this piece of glass can't possibly all be interconnected and sealed together. And so what you now have is where on most vehicles, this is a completely sealed unit front to back, your display. In this vehicle, you have an air gap between the display screen and the surface of your dash, of your viewing area. So what Tesla has engineered here is beautiful. They have what's known as the demister. When you're defogging your windshield, you're here. When you're demisting, you're clearing the glass on your side window of your car. So what they've done is they've beautifully incorporated this demister right into the underside of the IP, of the pad. And then behind that, and I'm hoping you can catch this on the camera, you'll be able to see, because this is not just a reflection back there, there are actually a lot more vents here. They are having to defog or demist the back side of this front surface in order to not have your display panel fog up on you. So that's something that's unique to having this entire front surface be one continuous surface, one continuous viewing area. Also unique to this demister here is that you don't have a bezel on top. Normally, if you just look in your own vehicles at home, what you're going to see is that there's a separate bezel that typically sits on top of your dash and blows sideways towards your your door window, your driver's and passenger door window. This is completely hidden. It's a gorgeous execution. Also, what I'm going to talk about at the same time here in general is their HVAC ducting and execution. Like Carl was saying, this is heat welded. It's plate welded onto this surface. So first, they put the wrap onto the surface, then they heat weld this on. Well, when they got here, they kind of had a problem. They had to go around the speaker opening, so this piece of the duct could no longer be integral into this top pad substrate. So they had to bolt this short section on separately from the heat welded plate.
So they're kind of making a bridge there to connect the two. And on one hand, you would think, well, that's kind of a lost opportunity. They almost had it. They got so close, and then they were cut back and destroyed by the geometry that their part has. Now for these vents, we're going to get a little farther into the vents, but I just wanted to make mention of the wrapping. This is a condition that has been brought up and has been asked about by some of the customers that I've worked with in the past. They want to get rid of the vents themselves, so they want to narrow it down. You have this wrap material, but I have a problem. You can see right here how the skin wrapping, as it wraps up into the area that is the vent, you can see that cut. You have multiple cuts around this area. That is an exposed edge of the vinyl, and this is a water-based adhesive that is holding this down. Now, your heater has conditioned air, so now you have heat, you have humidity going right across a raw cut edge using a water-based adhesive. When you do testing for any type of wrap material, they are going to do heat and humidity testing. However, they are going to have a big panel, and then they are going to peel sections in the middle of this big panel. I have asked several of my customers in the past, how are you replicating this type of a condition in heat age, in humidity testing for peel adhesion over a 10-year cycle? I haven't seen anyone do it yet. A lot of people want to try and work towards this condition to kind of narrow things up as best they can. And hopefully for SIA, who made this top pad, and Tesla has come up with a way to test that to see if that adhesive bond can survive in that type of condition.
And while Carl's talking about his loathing for that fiberglass, and I will second that. Anytime you've worked with parts that have exposed fiberglass, you don't suffer just those few minutes you're working with the parts. Those little particulate glass fibers embed into your skin, and that itches a long time.
It reminds you when you're trying to sleep that night, laying in bed and just feeling it on your arms.
You just want to rip your skin off. So going to this piece, which is also a component of the instrument panel, it has, instead of being the glass fiber PP, I'm going to have Carl discuss this piece. There's this whole section right here, this perforated section, which has the fan that draws in past this thermistor, the interior cabin air to measure the temperature and be able to do your automatic climate control.
So, a couple of things here. Going from the wrapping itself, then into the mechanism that they've put into this part. This is PCABS. Glue sticks to PCABS, so we don't have a problem there. All right. This has perforations. Most likely this is a punch process that is put into the vinyl. Here's a problem. They're using a spray adhesive. So think about all of the steps. You have a raw substrate with holes in it, setting that down. You're going to have to mask the areas of the holes, spray glue onto the A surface. You have a cut piece of vinyl with all of these holes in it. You're going to have to flip that over. You're going to have to mask the areas of the holes, spray adhesive on that vinyl. Then you're going to have to bring those and put them together and have critical alignment. If you can see through those holes how they match and line up, More than likely, they had to have some sort of a fixture that would provide pins through there to enable that alignment. But now I'm wrapping, I have some sort of alignment holding me in place, sticking me down, but I masked the whole area on the substrate, I masked the whole area on the vinyl. So there is no adhesion immediately at these holes. I can push up a huge wrinkle. Now, if this was a microphone, I wouldn't have any problem with that. However, this is a sensor that is pulling in cabin air. So again, we have conditioned air passing through these holes that already has a bunch of delamination. Maybe for this condition, it's not a problem, but I have had customers in the past asked to do this for air vents, heat vents, microphones, speakers. It can be done, and there are methods of doing it. And there are at least 2 other methods of adhesive application that I can think of for this. But now at Munro, we talk a lot about costing. All of these process steps, every time you touch something adds cost. Well, think about the B side. Hand me that part right there. This one also has edge wrapping, and you can see that this was sprayed. There's a nice even coating right through there, lays fairly flat. But look at this. See the bulkiness and unevenness in that glue layer? This was brushed. Someone actually sat, after they flipped this over, since it's a contact adhesive, you must have adhesive on this plastic. I'm betting that they hand brushed adhesive on there, let it dry, and then wrap over. It makes this for a very complicated part to wrap, a very expensive part to wrap because of that condition. We will talk more about this in a minute, but let's go back to the ducts.
So returning to our ductwork here, if you've sat in a Tesla and played with the heat and ventilation system, what you find is that the air just magically changes direction right to left, up and down. You aren't seeing what is very typical in every other automobile, which is this type of event system, where you have, first of all, a lot of real estate on your instrument panel taken up.
Yes, and I've worked with studios when we're talking about the surface, going right back to the studio when they're trying to draw this stuff. They have to set boundary conditions, typical cross sections. Studio hates a commodity like that because they tell them, well, we need a certain cross-sectional area for the air movement. Okay, but each of these veins has to have a certain area for it to travel and exist in. Okay, so that's growing it bigger. Then we need to put some sort of a decorative bezel. Okay, well, there has to be a certain amount of overhang for the decorative bezel. This part grows and grows and grows, and then the studio has to try and design and work around it. You are also paying an awful lot of money for this. You're paying money for all of these molded components. You're paying money for a trim cover. You're paying money for the paint or chrome application, all of the different mechanisms that you are touching. You consider that to how much is actually exposed on the Tesla, and it's just an open hole. All right, so if this is a premium vehicle, you have this where you're paying for all of that trim. You have this that has a sleek, smooth look. There is no trim. You can actually get rid of the expensive component, and because of the execution, have it actually be a higher end trim level. And that seems kind of funny to people. It's like you're getting rid of features, you're getting rid of decoration, and making something more expensive. And that's perceived quality over the actual cost of the components that go into it. That's a very important thing for an automotive company to be able to bank on, is the value of nothing.
And as we all know from many episodes of Munro Live and in general as engineers, what's the best part? No part. Always, the best part is no part. So while you're just so used to seeing these things, and in the last few years it's become exotic to do like aviator style. I'm sure that our amazing videographers who are standing behind the scenes all the time can find a picture of the round aviator style bezels that became popular and became repopularized again. So yeah, that's an interesting trim feature, but the best part is still no part. Now, so what you do normally as a consumer of this, a user of this, is you are touching on here sliding these vents back and forth. So like Carl was saying, not only do you have to have space for all of the vents and the bezels and the louvers, you also have to have space for the roller controls on both sides. You have to have this tab sticking out. So what Tesla has done is all of these items, in this one you can see, this is the door that controls whether it's open or shut, and it's actuated by this device here. So you can move that door back and forth, open, shut, with this device. This is an actuator. And in the Tesla, this door is now the blend door between this lower vent and this upper vent. So there's two sets of actuators, one for the lateral movement of the air and one for the vertical movement of the air. And these two motors here are driving the actuation. Different from your standard system, the lateral actuation is still louvers. The vertical actuation has nothing to do with louvers anymore. Tesla has used two air channels, the top air coming from here and the lower air coming through here, which is controlled, I'm going to flip this vertically, by this blend door here. So when this door actuates, it goes back and forth this way, and it controls the amount of air either passing through the lower or the upper in such a fashion that the two air streams blowing at each other direct the air up or down. If you have more pressure coming from the lower, it's going to direct the air up. If you have more pressure coming from the upper, it's going to direct that airstream down. So they've done away with an entire set of louvers as well as cleaning up the IP and getting rid of this entire feature here.
Now, they're getting rid of that feature, but they are still putting a lot into the B side. There is still a fair amount of packaging space that is required for this, but I would assume that the depth into the IP is somewhat reduced. Because you have this entire packaging space here, but once you're putting in ducts that also have to have elbows, that's growing back farther and farther. There is a way to integrate some of this stuff into the components that they have.
So back to the ductwork over here, the piece that Carl just had in his hand right here is the traditional way that HVAC ducting was accomplished, getting the air from the HVAC system blower to the ventilation points in the vehicle, the apertures. And this is a thermoformed piece, or blow molded piece, where they basically drop a tube of plastic, capture it and compress it, and it blows out against the mold.
So why do I not want this in my IP? One, it's very, very loud, which causes BSR issues. All right. It's very, very stiff, which means if I have a very tight tolerance or bolts that I have to get to and try and reach, this is in my way and it has no give. So we have BSR, we have this stiff component that has, and it's a little heavy, not that heavy, a little heavy. An older style of improvement here, which improvement on weight.
Definitely an improvement on weight. This is the same stuff as your egg carton in your fridge. It's really lightweight. It's also compressible. It's flexible. So
if I was fighting to get to that bolt, I can slightly push this out of the way. It's not going to cause too much of an issue as long as I don't break it. But they did something even a little better than that. This is from the Tesla.
So this is the Tesla's actual ductwork here, and what you can see is it is a polyethylene terephthalate material, which is PET, which is the same thing as your bottles, your plastic water bottles are made of, and it's blended with polypropylene, which gives it some additional structure. It is kind of a mesh fabric, and that's beneficial in a couple of ways. First of all, they heat stake the edges together, so that's very easy. They don't need glue. They don't need any kind of a special bonding process. It's, as you can see, thermoformed. It's very easy to form because of it being a thermoplastic material. Another benefit of using the PET polypropylene blend is that you can use recycled materials for this, so it helps with being green as well. Additionally, relative to noise in an electric vehicle, we know that silence is paramount because you don't have your engine noise. So this ductwork, first of all, it's soft. You're not gonna buzz against things. You're not gonna squeak. If you've ever closed your egg carton and heard it squeak, you know what I'm talking about there. You're not gonna rattle against a hard duct. This is quiet. Secondarily, as your air passes through this, there are oftentimes little baffles or little added on pads that I've seen inside of those type ducts. This already has the soft material integral in the part, so you don't have your resonant air frequency noises happening in this. I think that's about all I can say about this ductwork. Anything else you wanted to add?
Well, the only reason why I bring up the fact that having something flexible is very beneficial for getting bolt access is because I had to take this thing apart. And I think I took it apart in the wrong sequence. I do believe the entire HVAC system had to come out before the top pad, and there was one bolt that I could not get to. And this piece right here, I had to nearly crush to get out of the way to get that bolt access. And even though I nearly crushed this, it's still in good condition.
100% intact.
I want to bring that up just because I fought for about a half hour yesterday to get that last bolt out of there.
All right, we're going to move to an entirely different topic, but it's covered here because this is part of the instrument panel. And if you've watched Elon Musk's videos about his Model S latest development, it's the bioweapon defense mode. And we laugh. So that is a funny name for it, absolutely. But it really is a valid thing that Elon has dramatically improved the air quality in this vehicle. It's actually unbelievable how much the air quality will be improved by this system. So if you take a look just at the stack, first of all, right here, this is the air filtration that Elon has in his vehicle, the Model S, since 2021. If you take a look here, this is the entirety of what's in the Mach-E. And I'm going to hold these up to a light somewhere, and if you take a look, there's virtually no light coming through this piece, which is the cabin air filtration, as compared to the Mach-E's filter. It's also much, much heavier, this one.
So you just said cabin air filtration. Of course, the Mach-E only has one. This one has two. So the two different zones that we're looking at here?
So this is a large filter. This is a HEPA filter. Anybody that doesn't know what a HEPA filter is, it's a filter that by the DOE regulation has to remove particulate matter at a 99.9% efficiency, anything that's below 0.3 micron, or anything above 0.3 microns. So 0.3 micron and below can get through this filter, but not above. So this is what you know, maybe when you've taken your lawnmower filter out and knocked it out, this is the portion of the filter that captures the main dust and debris, the large particulate matter. You know, you take it out of your mower, you tap it, knock it clean, and that's pretty much all that we have here. Another difference right here is that this enormous filter is for intake of air. This filter sits up in the front of the Model S. It sits behind the frunk, under the dash panel of the Model S, way up front, and air that comes into the vehicle passes through this first. On this side, which is your business end of your HEPA filter, this is activated charcoal. This is carbon that you see here, and this is a very fine mesh. It's a non-woven mesh, and this is where you're really taking out your particulate matter. So any air that comes into the vehicle passes through this. Next, once you're within your cabin and you're recirculating within your cabin, it comes through the same type of material on a smaller size filter, and then exits through this side, which is even more dense. So when you're using your bioweapon defense mode, what happens? Laughter is okay. It really is a button in there that shows bioweapon defense mode. Your fan in your HVAC system kicks on to high pressure, and it is basically pressurizing the cabin so that all the air that you're breathing is passing through both of these filters. And then air is not coming in from the various leak points in your vehicle. Maybe along your windows, there's an exhauster that maybe some of you don't know you have, that when you shut your door, it's why your windows don't pop out.
Which happened to me. A cheap 1990 Cavalier when I was in college, shut the front door and the back window popped right out onto the tailgate.
That's craziness.
Yeah, so it was for me too.
And the reason it doesn't happen typically is because usually in the back quarter panel or wheel well or trunk area of a vehicle, there are these two openings that are called exhausters or vents, exhaust vents, that when you slam your door and that pressure increases, little rubber flaps open and it allows that air to exit, little flaps close back down on these vents. That is an air ingress area. That's an air ingress area where this pressurization of your cabin will force air to exit instead of coming in.
So another big thing about an instrument panel is safety. And safety is one thing that I care quite a bit about. This IP has 3 airbags. Passenger airbag module that we see here, and then 2 knee airbags. I took one of the knee airbags so I can talk about it a little bit. Eventually, when I completely disassemble these, we're going to take a bunch of pictures and then I actually want to cut them open. I want to see how they weakened this for airbag deployment. The airbag has to break through the plastic substrate on both of them, and then the airbag has to break through the covering material. I don't know if you can see in the lighting, but there is an airbag weakening line. It's in the shape of a U that you probably can just see. We might have to take still photograph for you to see it. All right, this is a U-door. When that airbag is opening, it is hinging across this surface and then opening up. Well, think about the way those forces are being applied. So if I'm hinging here and I am lifting up here, I am creating delamination forward of this line. All right, so my tear line is actually going to be forward. All right, what's happening on this being a wrapped part? Well, let's look. This is a glass-filled polypropylene part, which they had to flame and then they had to spray with a contact adhesive. I would say that they designed this part wrong. This is why. These hooks. If this was just a normal part, direct injection mold in color, these hooks going right to the edge are fine. But since this had to be a wrapped part, you'll notice the wrap and the adhesive had to go underneath the hooks. They should have sunk these hooks back so that they had a complete exposed edge for the wrap. Where did that cause a problem? The flame head. You're trying to drag in a flame head, but these hooks are shielding the flaming from getting into this area. Then you're coming in with a glue spray. These hooks are shielding the glue spray into that area, which has caused delamination. This whole forward lip is delaminating. All right? That could happen. If this is hidden, if it's trapped, maybe that's not a problem. But this is a U-door. Since that U-door is forcing delamination into this area, that part is already delaminated. Quality control, I would say this is bad. It's a poor design. It should have been changed a little bit. Also, I hate U-doors. H-doors are so much better as long as they can work within the structure of the vehicle. I've had very, very few failures with an H-door. I've had a lot more with a U-door design. Once we can actually get these things ripped open, then I can look at their method of scoring or weakening these covers. Some cover stock material does not need to be weakened, so the material is considered self-tearing. Sometimes you can create the entire sandwich together and then you can laser score it. I can tell you that those lasers, however, cost between $1.2 and $1.6 million. So it's not something that you want to do if you don't have to. Sometimes you can weaken the cover and then weaken the substrate independently and then put them together. But then how do you align those score lines, which you should not be able to see? That comes into some very expensive and very complicated fixturing.
So some of you might be wondering, okay, this is a cheap little air filter here. How much do these cost? Well, Munro's estimate is that this HEPA filter right here adds $50 to the cost of the vehicle.
And that
roughly
is-
speaking, about $5 for this. So you're talking $55 right
and
here.
that is the manufacturing cost. That is
Right.
not the cost that you would be paying for the finished product.
So if you own a 2012 through a 2020 Model S, Tesla is now advertising that you can add this system to your vehicle for an additional $500 cost. I believe that probably includes adding a different holder in the front of the vehicle in the IP, the housing for this. The benefits of this are that the exhaust from the non-BEV vehicles out there, that is a larger particulate than the HEPA filter pores. And so you're not going to smell the exhaust. When you go into densely populated city centers, and this is especially important in places like Shanghai or various cities in China where the air pollution is nearly palpable. You feel like you're swimming through it there. For some of us, Carl, we probably aren't as concerned about that.
I live in the country. Where I live, the houses are only on one side of the street. This is a cost-benefit analysis that I would not make for my own vehicle, my own choice. But there is a large section of the population who this would really, really benefit.
Now, for me, it would really benefit it because allergen particles, the dander, the pollens especially, are large particles, and this will completely trap and eliminate those allergens. So as you're traveling and your allergies are acting up, this is a beautiful thing.
So, thank you very much for watching this video, trying to go from the IP through the ductwork. Thank you for watching Munro Live. If you have not subscribed, please subscribe. And I guess that's actually normally your line.
Yeah, it is. So we may modify that a little bit. So anyway, I'd like to thank Sue and Carl for a wonderful demonstration of what goes on here with the IP on the Model S Plaid. I hope you picked up a lot of good stuff. But I'm going to end kind of in a different way. Now, when we did the Model S Plaid motor, and I talked about the carbon fiber wrapping, I said this might be just a short, like something to get into the business, but ultimately they're probably going to wrap it with either a knitted or a woven product made out of carbon fiber. To those folks who said I was full of you may want to have a look at this. Okay, I don't know who sent this to me, but I know where it's from, and I know which direction Tesla is heading. So if you were quick to hit the button that said, "Oh, Sandy, you don't realize about expansion and all this other stuff," you remember that on the Model S Plaid motor, there's sections that are loose on the top. They could go this way, but they could also go that way. And that's why when I said this is probably going to be a woven product, here it is. So anyway, thanks again for watching Munro Live. Thank you again for a wonderful presentation. And if you've got a mind, please subscribe. And if you're interested in the laminates, they're going fast, and we've also found somebody who can basically gold plate these things. So we're only going to be doing 20 of those, and Corey will have them up, I'm sure, in the near future for sale. Anyway, thanks. Have a great day, and thank you again for watching Munro Live.